All right. So, yeah, we're going to be doing roses today, but today's about extrapolations. And then, as I said to my fifth hour before I started the video, at the end, I promise you, you will have a really good idea what equation makes these pictures. And that's ultimately what's probably going to happen on the AP exam. I'm not going to make you graph a rose by hand, but what you'll have to do, and I actually started a quiz is, I think I'm going to do it tomorrow with all of our stuff that we've already had. I just have to insert roses in there, all right? And then tomorrow's like a bring it all together day. Friday. What's today? Today's Wednesday? Oh, I just lost the day. I literally thought it was Thursday. My meetings in the morning scramble my mind so much that I feel like another day happened or something like that. Oh, great. Stuck here 2 more days. Oh, sorry. Didn't mean to say that in front of you. Okay, all right, here we go. Input, say it. All right, so we're going to go through this pain first of all, and then we're going to cut it short and go to Desmos. And I may ask her what time is it every so often because she's the time expert. Anyway, so we got to remember this for cosine. I think I have cosine to start off with. What is cosine of 0, everyone? What's cosine of 0? Remember that, because for roses, we'll either have cosine or sine. How they start, we'll tell you. Remember I showed you at the end? After what I do today, you should know if I have sine or cosine right off the bat, and then you should know about the rose petals and what numbers go where, and it's pretty not bad. But this looks horrible, and it kind of is. All right, but anyway, so when I plug in 0, cosine of 0 is 1. 1 times 4 is 4. So 0 comma 4, 1, 2, 3, 4. There's our first point. That's how this graph starts. Bless you! Now, I'll tell you later, you don't have to worry about this now, but later you are going to have to know intervals and which chunks of the graph are created by what interval, what inputs. Say it again, input. But right now, we're just doing it to get this little thing here. Then I kind of screwed this up yesterday or last hour. I looked at this, but wrong. This is the input, pi over 12, because what's 2 times pi over 12? Pi over 6. And then that's what you're cosining. Cosine of pi over 6 is root 3 over 2 times 4, so that's approximately 3.5. So pi over 12 is what I plugged in, though, to get pi over 6. Cosine of pi over 6 was that thing that gave me 3.5. Really hard. This hurts my eyes. And then pi over 8. Why? Because 2 times pi over 8 is pi over 4, which is one of our unit circle values. And then that becomes 2 root 2, which is 2.8. 1, 2. You can check those decimals. It's true. So you are going to have to do something like this next week. Like what intervals create this part of the rows. And then pi over 6 times 2 is pi over 3. That's the half value. So pi over 6 I do have. Pi over 8 I don't. So I put that in the wrong spot, right? That's pi over 6. So pi over 8 is not even on here. So I made one mistake. That's like kind of floating in the middle. Because pi over 8 is between pi over 6 and pi over 12. This is what I mean about this being a pain. I've already made a mistake. All right? 2 times pi over 6 is pi over 3. And then that gives me 2. So pi over 6 comma 2. Really hurts my eyes. All right, and then we keep going. And I actually shorten this up pretty fast here. Well, no, actually, it's pretty good. 2 times pi over 4 is pi over 2. And that's what we really want to search when we're input, outputting, and trying to get our graphs. What are my 1 and 0 values? So when I plug in pi over 4, 2 times pi over 4 is pi over 2. Cosine of pi over 2 is 0. That's where I'm at the origin. So here's our first little part of the graph created in order. And that's from 0 to pi over 4. This is what I mean about you will have to have this analysis maybe next week. Input, output, and so on and so forth. For today, this is just an extrapolation, and then I'm going to go to Desmos and kind of cheat. I'm actually going to go to Desmos pretty quick. I'm not doing this whole thing all the way through. I think I stopped after the next pedal. All right, and then now we go to pi over 3, but now I get thrown into quadrant 2, because 2 times pi over 3 is 2 pi over 3, and now I get a negative. So here's what I plugged in. I plugged in I did plug in pi over 4 and I got 0. And then I plugged in pi over 3. And then what I ended up getting was -2. So how does that graph? It doesn't graph up here, 2 comma pi over 3. It flips over to really where 4 pi over 3 is. Okay, and then it's 2 out there. So the order that this goes is from here, then to here. This is how this goes in order. So you kind of do have to know about this later, the progression of this graph. When we go to Desmos, you'll see this progression, and you'll see how it's created. And then I'm going to verbalize my input outputs when I go to that. But what I do want to do is finish this off. Okay, we kind of get it. Let's go to this. Why is pi over 2 a good value? 2 times pi over 2 is pi. That's what we're searching for, our pi and pi over 2 outputs. Or, you know, when I throw it in, I get those. Because then the cosine of pi over 2 is 0. I'm sorry, let me do that again. Pi over 2, wrong. Pi over 2 times 2 is pi. Cosine of pi is -1. -1 times 4 is -4. So, pi over 2, comma, -4. That's why this goes down here. So that's part of that rose petal. And then literally last hour I stopped. I stopped here and I said, okay, you feel free to look at all these other ones and graph them. This is a Wednesday. We are short on time. And even me doing this, I still went to the bell with last hour. And then I talked about some extrapolations. So here how this Desmos works. You have this on your calendar and you get to play with it. What Karen and I, or Mrs. Cooper and I, worked on was getting this to work so we could see this in action as we pull it. And we did want both sine and cosine separated, so I could do either one and toggle between those. And this is what I don't have. What did I have? What was it, 4 for A, right? So it's easy. 4 is just how far out the petals go. So it's the farthest out it goes from the pole. And then it is 2, right? 4 cosine 2. So you just toggle these, and now I do have 4 cosine 2 theta, and now I can pull this, which makes the graph. Isn't this how we started, right? And isn't this how we ended up here? And then I stopped the notes there. But look up here. This is close to 1.57. So that's close to pi over 2. That's what I want you to understand. Okay, so you kind of have to have an understanding of the decimal inputs. Why did I lose my toggle? Oh, because I hit that up there. Okay. And then as I keep going, let's see when it goes back to the origin. What's that, and what would that be? It's an over 3, if I have this right. No, an over 4. Let's think about that there. I think it is an over 4. It's kind of hard for me to think about this as well. Because I have a 2 times here, and then what's 3 pi over 4 times 2? What's 3 pi over 4 times 2? 3 pi over 2. What's the cosine of 3 pi over 2? 0. 0 times 4 is 0. That's why we're back at the pole. Got it? So I don't know 3 pi over 4 is 2.35 approximately. I'm thinking, how did this happen? All right, and then the next thing is, I'm going to pull to the next rose petal. So the next end. How did this happen? Well, that's at pi. Oh, and it does say pi right there, right? So what's pi? When I plug it in, well, it gets multiplied by 2. What's cosine of 2 pi? What's cosine of 2 pi? 1. What's 1 times 4? 4. So pi comma 4. That makes sense. Got it? All right, and then I'm going to go back to the origin, all right, and think about that. What would that have to be? Doink. Okay, well, I need an over 2 there. I don't understand that 3.9 that I have there, so I got to use my brain. I think it's 5 pi over 4. Is that right? 5 pi over 4 is in quadrant 3, right? And then 5 pi over 4 times 2 is 5 pi over 2. What is 5 pi over 2? The same thing as pi over 2, all right? Which is, cosine of that is 0. 0 times 4 is 0. That's why I'm at the pole. All right, next one. Let's get to the next high point, or the next rose. What could that be? Well, I need a pi or a 2 pi. And I know 4.71, I think it's 3 pi over 2, right? Okay, so that's when I plugged in 3 pi over 2. So when I plug in 3 pi over 2 times 2 is 3 pi. What's the cosine of 3 pi? What's the cosine of 3 pi, which is over there? -1. What's -1 times 4? -4. So look at my cursor here. 3 pi over 2 comma, yoink, -4. It gets flipped over across to the other side. That's how you do points. Are you listening? Okay. All right. And then the last one is 2 pi times 2 is 4 pi. So that's how you get, oh, I went a little too fast there. Okay, so what do I need on this one? I got to think about this one. Is it 7 pi over 4? I think it is. All right, 7 pi over 4 gets me back to the origin because that turns into 7 pi over 2, which is the same thing as 3 pi over 2, which is 0 for cosine. All right, and then I jumped a little too quick to 2 pi. 2 pi gets me that 4 again because cosine of 2 times 2 pi is 4 pi. Same thing, it's 1. So I get 2 pi comma 4. And then I end up right back where I started. Hey, how many petals do you count? 4. And this is it. We don't have the time. This is really all you need to know. Okay, I'm going to move this. Don't look. Don't look. Don't look. Close your eyes for a second. Doink, doink. Okay, up. Oh, okay, I went too slow. Okay, look, what did I change B to? 4. How many petals do you count? 8. Okay, what's going to happen when I change B to 6? How many petals? Close your eyes. You didn't close, did you? Okay, open your eyes. Okay, I just didn't want you to see the odds yet. All right, how many petals do you see? 12. And then I'll show you how you know the difference between cosine and sine. What's the cosine of 0? What's the cosine of 0? 1. Look what that petal is. It's 4 comma 0, right? That's because cosine of 0 is 1. Now let's toggle the sine. And then you kind of have to watch this. You get them both at the same. Ooh, isn't that pretty? That's like a spirograph. You ever heard the spirographs? Anyway, just had a flashback. I remember that when I was a kid. Why is the sine graph not on this x-axis if you think about a rectangular plane, a coordinate plane? What's the sine of 0, everyone? 0. So you start at the origin when you do sine. You know, and this is getting low. Can you imagine graphing this by hand? Hi, caramba. What a jerky question that would be. All right? We can be jerks, but anyway. All right, so that's why, let me go back to the toggle here. The sine of 0 is 0. That's why we start at the origin. The first point that you graph is the origin. And then look at this. Where do you think that's at? Where do you think that's at? Where's that highest point there away from the pole? Pi over, that's all I'm asking. No, not pi over 2, pi over 4. Why? What's 2 times pi over 4? Pi over 2. So this is input, say it. When you have to graph this by hand, what I got myself down to is just where are the ends of the petals? They're going to be at all the over 4s. Because what's 2 times over 4s? Over 2s. What are signs of over 2s always going to be? Either 1 or -1. So that's why in order, watch what happens next. I'm going to toggle this, and then where do you think this is going to go next? Quadrant 2, 3, or 4? What do you think? Is it going to go 2, 3, or 4? It's actually going to go 4. Why? Because this is when I plug in 3 pi over 4. 3 pi over 4 is over here. Sorry, you can't see my face anymore. One sad thing about our change in movies, I like having my fat face on the graph too, but also you can see when I'm pointing up here. So here's 3 pi over 4. When I plug that in, that's 2 times 3 pi over 4, which is 3 pi over 2. What's the sign of 3 pi over 2? -1. -1 times 4 flips it over to here. That's why this is, you're going to have to know this. You're going to have to know, like, next week, like, what interval is this? What interval creates this part of the graph? And it's actually, if I remember correctly, from pi over 2 to 3 pi over 4. You are going to, not now. I want you to get the basics and this extrapolation. But eventually, and this can help you. This is helping me. This helps me. I like this. All right, because I always had a hard time with, hey, what part of the rows is created by, what inputs? All right, and that's what this is going to do for you. Notice I just passed 3.14. When I plug in 3.14 pi, 2 times that is 2 pi. Sine of 2 pi is 0 again. That's how you get back to the pole. All right? Really, this is the best way I can think about doing this. I'm glad we made this decision during our meeting today to just get this done. Otherwise, the notes would have been a disaster, I think. In my mind. How did that happen? Remember, you're in quadrant 3 now. This is what this toggle does for you, 3.96 for an angle measure that I plugged in here. So that's then over 4 again. That's 5 pi over 4. Multiply that by 2, you get 5 pi over 2. 5 pi over 2 is 4 pi over 2 plus pi over 2, you get 1. All right, so sine of 5 pi over 2 is 1. 1 times 4 is 4. So that's at 5 pi over 4. All right, and then the next one, let's get back to the origin there. That's probably 4.71 is 3 pi over 2. 4.71 is 3 pi over 2. 3 pi over 2 times 2 is 3 pi. Sine of 3 pi is 0. That's why you're back at the pole. And then the last one is a flipperoo. This is actually 7 pi over 4. 7 pi over 4 times 2 is 7 pi over 2. That's 4 pi over 2 plus 3 pi over 2. Sine of 3 pi over 2 is negative 1. So 7 pi over 4, comma, negative 1 times 4, yoink, flips over to this side. That's this rose petal. So this rose petal, know the interval that was created, that created that one. And then back to 2 pi. 2 times 2 pi is 4 pi. So you end up back at the pole. All right. I'm not even going back to the sheet of paper. I'm sticking to this. By the way, this is fun. Doink. Remember the circles? Remember 4 sine theta or 4 cosine theta, right? Right. And I don't know if I wonder if I can do this. I was curious. Let me put a negative. Let's see if it flips it. Hey-oh! Right? Remember we talked about that? So someone asked me about what does a negative do to the rose petals? And I might play around with that when we get to that. Doink, doink. And then there's sine down and up. So that's not a rose. That's just 4 sine theta now. 4 sine theta. Okay, let's go odd. This is why I told you to close your eyes. Close your eyes. I just remembered that song. How many petals do you count? 3. What's our B value? 3. This is weird. I was wondering, this morning, how can we tell them why do we only get 3 petals with 3, but why do we get 4 petals with 2? It's because of that negative radius, and it flips it over to the other side, and it creates those loops in a different way. I wanted to do this. Let's go back to 4 theta and see how this is created. This is wild. So I went to 4 with a sine. 1, 2, and then 3, and then when I get past, I got to get my 4th petal, and I'm going to have 8. Then these create new ones with negative radii is kind of what's happening here. So this never overwrites on itself from 0 to 2 pi. Got it? I don't know if this is going to help you. Now I'm going to change this to 3 and then do that toggle again and then show you how this is created. Okay, so first of all, it's sine. What's sine of 0 again? What's sine of 0? So you start at the origin and then it comes from there. And then let's analyze this first one. Why is it pi over 6 that's good? What's 3 times pi over 6? This is the kind of stuff you do have to do today. What's 3 times pi over 6? You're searching for pi over 2 and 3 pi over 2. Pi over 6 creates pi over 2. What's sine of pi over 2? 1. What's 1 times 4? 4. That's why that is pi over 6 comma 4. Got it? You better. All right, and then next, doink, 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 doink. What is that one? How do I get to 0? Probably pi over 3. Because what's 3 times pi over 3? Pi. What's sine of pi? 0 times 4 is 0. So that's from pi over 6 to pi over 3. That's what this interval is here. This is the kind of stuff you might have to do next week. A little bit rough. All right, and then let's talk about this pedal. Ooh, what is that exactly? That's 3 pi over 2. But guess what? It's not. It's actually pi over 2. You know why? What's 3 times pi over 2? What's 3 times pi over 2? 3 pi over 2. What's the sign of 3 pi over 2? Negative 1 times 4 is what? So it's pi over 2, comma, yoink, negative 4. There's our flip across the pole. That's how you graph a negative radius. And then the next one, this is probably 2 pi over 3. I don't know 2 pi over 3 is a decimal, but I know 2 pi over 3 times 3 is what? 2 pi. What sign of 2 pi? 0. No, sign of 2 pi is 0. 0 times that, that's why we're back at the pole. Now let's go to the next one. Yoink. Okay, and then what's that one probably? 5 pi over 6. Because what's 5 pi over 6 times 3? Cancel the 3 and a 6, you get 5 pi over 2, right? 5 pi over 2 is 4 pi over 2 plus pi over 2. So sine of pi over 2 is 1. 1 times 4 is 4. So this is at 5 pi over 6, comma 4. That's what this point is. Then watch what happens. We get back to the origin. That's right around pi, because pi times 3 is 3 pi. Sine of 3 pi is 0. And then after this, when it's odd, the pedals overwrite themselves. They just keep going and pasting on top of itself. So when you have an odd number, the graph is complete from 0 to pi. When you have an even number, you have to go all the way to 2 pi to get your full set of graphs. All right, we used to do a correlation between a rectangular graph and what happens with this as well. There's a whole bunch of different ways you can approach this to make this make sense. You know what? Somebody asked this question when they left. What happens when I put a negative? What I think is going to happen is this is going to flip up here, and these are going to flip down here. Just like a x-axis reflection, right? 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 Right. So they did ask that when they left. Isn't that interesting? Yes, Mr. Samuelis. Okay. Thanks, Danny. You're welcome, Mr. Samuelis. Because no one talks to me, so I have to talk to myself. Just like at home. You should see dinner when we're all eating together. Sammy doesn't anymore. She's too good to eat with us. But anyway, Lexi and I. Lexi's got her earbuds on. And then I ask her a question. She's like, what? Oh, you can't see my face. My jokes don't work as well on these videos. They ever tell you about my ex-wife? Never mind. I'll get in trouble. Don't want to get in trouble again. All right. In the principal's office. Okay, so let's go to 5. How many pedals do you count, everybody? 5. What's going to happen when I go to 7? 7. Notice sign. Notice sign. Look at this. This is because of pi over 2. Ooh, is that true? Yeah, because 7 times pi over 2 is 7 pi over 2, which is the same as 3 pi over 2. So pi over 2 comma negative 4. But then notice when I toggle the cosine. This is how you recognize cosine from sine. See cosine? Look at our first pedal. It's here because what's cosine of 0? What's cosine of 0? 1. So that's how you recognize a cosine between a cosine and a sine rows. Got it? Then, you know, there's other questions on here. I read through this and I'm like, there is no way in heck we're getting through all of this. No way. But you know what else they asked? They being the other two. How far are these pedals away from each other? Well, this is a bad one. I'm going to need your calculator. But what's a full circle in degrees, everyone? 360. How many pedals are there? 7. So how far do you think those pedals are? 360 divided by 7. Very simple. Because they are equidistant. They do bump equidistantly around. These pedals, not one set of pedals are closer to the other ones. They're all equidistant all the way around. Now, to know what this is, that's a nightmare. All right, that's why I mean input, say it. No way. There is no way in heck that this is the way you're going to graph. You will never have to do this. This is an extrapolation. This was to start the idea of what occurs. All right, and that's it. So we did the three theta thing. How would I go about maybe graphing by hand if I was forced against my will to graph by hand? By the way, what time is it, ma'am? 108. You had to look. You're losing it. You're losing it. All right. So how would I do this like by scratch? And I actually did this the other hour. I think I did take this one. Here, I wouldn't do this. This is not what we're going to do. Don't scratch it out. You can look at it later and see what happens. What I would try to do is create my petals. Number one, I know I'm going to have 3 petals. There is some memorization. Number 2 is I want to find where the ends of those 3 petals are. So the first thing I'm going to do is this. You know what, too, and I said this last hour. I think it's kind of wrong that whoever created polar coordinates, they called it r comma theta, right? When we did theta, it was r comma theta. That's the order. Because actually the input's theta. It should be theta comma r. I have to input theta to create r. Does that make sense? So that's why I'm going to put theta comma r for my coordinates there. Hey, what's sine of 0? 0 times 3 is still 0. What's sine of 0? So you start at 0. Now this is what I'm going to try to create. I'm not looking at that chart. I want pi over 2. Sine of pi over 2 is 1. 3 times what is pi over 2? I'm going to let that sit out there, fraction people. So pi over 6 is my next one. Pi over 6 times 3 is pi over 2. Sine of pi over 2 is 1. 1 times 3 is 3. So here's pi over 6. And then that's where one of my rose petals are. And then you know what? It does go like this in some way, shape, or form. That's the start of it. And then I do believe I'm going to go back to the origin. You know, I could make that happen. Let's plug in pi over 3. What's pi over 3 times 3? Pi. What's sine of pi? 0. So then that proves I end up back at the origin and that petal is complete. This is all I plug in. This is it. And then what else do I want? So I got pi. Now I want 3 pi over 2. 3 times what is 3 pi over 2? I literally just said it. Pi over 2. So I have to create another chart here. So this is pi over 2. Because 3 times pi over 2 is 3 pi over 2. Sine of 3 pi over 2 is negative 1 times 3. So how does this graph? Up here, wrong, go 180, 1, 2, 3. And then what ends up happening is this. You know, keep with the curve. That's kind of tough. And then maybe prove the next 0. What would that be? I think it'd be 2 pi over 3, wouldn't it? Because what's 2 pi over 3 times 3? What's 2 pi over 3 times 3? What's 2 pi over 3 times 3? You guys make me sad. What's sine of 2 pi? 0 times 3. So at 2 pi over 3, you're actually back to the origin. Got it? So we're kind of keeping track of where I'm at. So what did I end up getting there is 2 pi. So the next thing, thinking about the unit circle, is probably 5 pi over 2 I want. Which means I'd have to plug in 5 pi over 6. This is why we don't understand if you haven't verbalized one thing I've said today. What is 5 pi over 6 times 3? Nothing. 5 pi over 6 times 3. 5 pi over 2. Learn your fractions. What's sine of 5 pi over 2? That's 4 pi over 2 plus pi over 2. So that's 1. So I end up getting 1 times 3, which is 3. So it's at 5 pi over 6 that I get 1, 2, 3. So I used, so it goes like this, and then the last one, it's actually pi, because when I just multiply that, I get 3 pi, and I get 0, and I'm back to the origin. And then that's enough. Look at that's all I had to do. That's all I had to do to create all my petals. Oh, for an even rose, I think it's really sadistic to have you graph them by hand. I really do think that. That 7 one, oh my gosh, forget about it. But that 7, it's really mean. just have recognition. And that's why I said at the end, we should be able to match graphs. What time do we get out of here?
20.
What time is it now? 13. You know what? Let's see if you've had enough to actually do this. Try to get those equations real quick. I didn't get to that with the other hour. I think the general idea has been taken place. And what I would do is input, say it. I'd try to create some of these points, and then, yeah, it's got to be that one. You should have an idea, though, which one's sine, which one's cosine, and then what the number is on theta. And then the number for the radius is simple as well. So in our last 7 minutes, now 6, we'll just kind of let you think about that. This is really where the rows stuff comes into play. You will not, on the AP exam, have to graph those by hand. And if we do have you graph by hand, I hope we only go like 2 theta or 3 theta, you know, just to, you know, because 4 theta is a little sadistic. And I think you'll see how easy it actually is. It actually is pretty easy when you're in the mode of just roses. Did anyone have all their answers already? Is anyone done? Nice. Did you do it before?
Yeah. A little bit. I only did 2.
Lily, were you part of the donuts this morning? Did you have something to do with donuts this morning? I could have swore I heard your name as part of it. No, all right, never mind. Sorry to freak you out. Who gave me donuts? Oh, Gabriella Salerno. You don't know her? I just said her name online. She can sue me. You can tell her. She can take all my teacher money. I don't have any. Someone else has it. I told you about that. We can't mention her. I don't want to get in trouble. All right? I'm going through my taxes right now. Oh my gosh. I'm broke. The government. All right. All right, so what's this first one? Sine or cosine? This is a cosine. Why? Because cosine of 0 is what? What's cosine of 0? 1. And then 1 times 3 is 3. So guess what's in front of here? 3. And then what's in front of theta? 3. Okay? And then I could just check real quick, like some other values. Like this is 2 pi over 3, and then I could plug it in. What's 2 pi over 3 times 3? What's 2 pi over 3 times 3? Did he still not answer a dang thing? No, he didn't. Cosine of 2 pi is what? He still got his hand over his mouth. 1. 1 times 3 is 3, so that proves another point. What's this one, sine or cosine? Sine. What's the number in front of theta? 2. And then what's the number outside? Okay, that looks like this keeps happening. Why does that keep happening? All right, and then what's the number in front of theta? 4. Is it sine or cosine? Sine, because you don't have that point. And then what's the number in front of sine? 2 yet again. See, I told you. You know, if you can do that at the end, you've been taught and you learned. Okay? So, and I could input, output, like what I would do, oof, some of these are a little bit off. So like 4 times, I'm still blabbering. 4 times pi over 2 is 2 pi. That doesn't work. I'm trying to create these there. It'd be pi over 8. Oh, that's awful. So this happens at pi over 8, which is in between pi over 6 and pi over 12. Yikes. And then how do I get 3 pi over 2? I don't know why I'm still doing this. You get it. It's good enough. Okay, I'll stop it.